All right, I was asked to help troubleshoot student solution for exercise 7.3. And so I don't believe this is the first time we're looking at 7.3. And so it's our buoyancy problem. All right, so essentially it's our duck buoyancy problem, just like we looked at as one of the examples within the chapter. So we have our force balance. And so if I look at our simplified buoyancy equation here, or simplified force balance, okay, we know the density of the object. Okay, we're given the radius of the object. And in this case, we're going to be given the depth with which the object is submerged. And we're asked to solve for the corresponding temperature. Right? And so how we get temperature is if I look at my buoyancy equation, the only unknown is the density of the liquid. Right? So the density of my liquid's unknown. And we're given an expression for the density of liquid, which gives the density of the liquid as a function of temperature. Okay, so we're given parameters A, B, C, and N. So within this equation, right, we have an expression for the density of my liquid as a function of T. All right, so rho L is my only unknown in my force balance equation, which is equivalent to the only unknown being T. So let's go and take a look at the code. And first we'll start by seeing if there's anything obvious, all right, before we get into the nitty gritty, okay? And actually, come on, let's move my head out of the way. All right, so if I look at it, so we have this function that's going to take depth as an input. That's good because you're asked to take depth as an input and return back temperature. So we'll check these parameters later, but here's A, B, C, and N. That ought to be for my density equation. The density of my object, the radius of my object. And then look, we have this density. So this is going to be one issue, right? So the one issue I see is you're creating this anonymous function. So we have this density function, okay, which I'm guessing is my error function that takes A, B, C, N, T, right? A, B, C, N, T, what I'm trying to solve for, rho naught and D. So it's taking all of these as inputs, okay? And so you're defining all those constants. You're going to pass it to that function via an anonymous function, so that the only unknown variable left is T, okay? And you're assigning that to A, okay? So one thing I'm not sure how it works, I think it should be fine, is A is also the name of your variable up here. So I believe this should behave just like a variable assignment where you come up the right-hand side, and so this would be A, the constant up here. But it does seem a little odd, so we'll check into that. So then, assuming that's my error function, I solve, and res is T minus 273. That's because we're asked to return the temperature in Kelvin. So we'll check this to see if it's, using 273.15 makes the difference in terms of why you're not getting the answer. So here's density, A, B, C, and T, rho naught, R naught, and D. All those variables match up. That's good. Row 1, so you have this row calculator. This is good. So with that temperature, I'm going to pass A, B, C, and N to my density calculator here. A times B raised to the 1 minus T divided by C raised to power N. And so, what you're doing here is you're solving in terms of Kelvin, because if I'm not mistaken, the density equation uses temperature in Kelvin. Okay. The one thing I would do here is semicolon's not necessary in the signature, and then I would make sure I end that with an end statement. Okay. But otherwise, nothing's sticking out to me, right? So if F0 is going to keep systematically guessing temperature, you calculate the density of my liquid for each of those temperatures. You plug that into my force balance until you find the temperature for which that's true. Okay, so let's minimize this. Okay, and then I give some example cases at the end of the problem statement. So I say let's see, for 180 centimeters, you should get 243.0829. Okay, so let's try this. So let's try homework 73, all right, and then we can check units and everything in a moment. But for 180 degrees, I get 243.2329. Let's see if the issue is just that 0.15 Kelvin. So I get 243.0829. I'm guessing that's it. So if I, make that 273.15, right, then I get 243.0829, which is an agreement here. Okay, so that's cool. What if I try the other case value, 80 centimeters, negative 54.1430, 80, okay, negative 54.1430, which is in perfect agreement. Okay, so code was great. Only comment was no need for a semicolon in your function signature. Then I made sure I added the end to make sure that that function was closed up. Right? Ends are in theory optional, but then that introduced the opportunity to nest functions, which we haven't talked about yet. So if you don't intend to nest a function, then we don't want to. And so then the only issue causing the numerical values was here to convert temperature from Kelvin to degree C. It's not just, to be rigorously correct, it's 273.15 and not just 273, right? And that's what was causing your small fractional error. Okay, so actually that ended up being a pretty easy, straightforward one. All right.